So welcome to the event. So we'll be talking more about mastering the complexity of algorithms. Okay. So why I came up with this algorithm is basically, or this topic or the session is basically to understand how things works when there is a problem that is given, right? So as long as if you don't understand the problem or as long as you don't understand how things works, you will not be able to give solution to it. Okay. And if you don't understand how the problem will go through on a certain phase or how complex it is, you will not be able to give estimations. Okay. So that's the overall thing. So for example, we used to give estimates in certain way that okay, we will be thinking in lines of code or the amount of resource available and all other complexities. But the major complexities of any problem is not with respect to the lines of code, it's basically the actual problem itself, right? So until you understand the problem and you understand or classify the problem in a certain aspect, you will not be able to solve the problem and give a proper estimation. Until you figure out the difficulty of it, you will not be able to give the exact time how much it might take. There are certain problems which may not be solvable, such as traveling salesman problem. If you want to find the optimal path, it is not solvable. But there is a way to get a optimization problem into combinatorial or the decision problem based on certain questions. So we'll be looking into that. Okay. Now we'll be looking into the NP problem and NP odd and NP complex. So the complexity we need to understand is to make sure that we give better estimates, understand the difficulty, and also think in terms of efficient way of writing our code. Okay, until we figure out what complexity is, and then if you want to make it optimized, until we know the basics of the optimization or how it can be optimized, we'll not be able to optimize, right? So that's the overall thing. Two things you learn from this is whenever a problem is given, you will figure out whether this is solvable problem or not solvable problem, and also figure out how much estimates you need to give or how much difficult it is. That's the major thing you learn out of this event. So before going into this, right, if we don't figure out the difficulty of the problem, we cannot give the estimates, and also will not be able to figure out whether it's a solvable or non-solvable problem. Okay. Right. So before diving into the any other NP and NP odd and NP complex, we need to understand the basics. What is n squared, 2 power n, and n factorial. Okay. So it's actually simple. It's the time complexity or the time taken for a algorithm to run. Okay. So n is basically nothing but the n. We can say n is the number of elements in array. Let's take n is the number of elements of the array. So for example, each and every for there is one for if console and all, right. Each and every line takes say 1 second, and then we can say if there are four the whole algorithm takes 1 second. If there are 4 elements, it will take 4 seconds. Okay. So in case of n square, it will be what? 4 squares are 16. 2 power n is 2 power 4, 2 to the 4, 4 to the 8, 16, and then n factorial is 4 factorial is what? 6. 6 fours are 24, right? Yeah. So this is the time taken, 24 seconds. Okay. So 4, 16, 16, and 24 seconds. So these are time taken for the algorithm to run based on the problem. Okay, so for n, we are actually looping through the problem, so it will take n seconds. So let's not complicate with the n seconds. So next is n squared. Right now the problem is we have an array 1, 3, 5, 7, and 9, and a target value of 10. We want to find all pairs that sum up to 10. Okay, so we are putting 2 arrays now. We need to sum up to 10. So there is 2 loops, right? So n into n is n squared. So first there was one loop which is n. So there is 2 loops now, that is n squared. Now, right now this is a different problem. Okay. Yeah. So this is a different problem. The problem is basically what? I have 3 elements. I need to make sure that what are the possible subset can have out of these 3 elements. What are the possible subsets? And it can be empty set, it can be one set with only 1, set with only 2, set with only 3, set with 1, 2, 1, 3, 2, 3, and 1, 2, 3. The actual original set, right? So the why the 2 is because there are 2 possibilities, right? One is the presence of that number or the absence of the number. So if there are 3 possibilities, it will be 3. If there are 4 possibilities, it will be 4. Okay. So that is the main thing here. You need to understand here is the possible in case of any subset, the possibility is nothing but the amount of time it takes. Okay. Okay. Yeah. Yeah. Fine. So till now I think it's clear. Okay. So you understood n squared, and 2 power n is basically what? You're finding a possible subset. It can be 2 if there are 2 possibilities. If there is 3, there can be 3 possibilities. In this case, the 2 possibilities are the element is present in the subset or not present in the subset. Okay. If there are 3 possibilities, say for example, if you write a review of a hotel, it can be positive review, negative review, neutral review, and if you want to get a subset that can happen is basically what? It can be 3 power number of reviews or the number of restaurants or number of person who wrote the review. It is based on the problem. Okay. So any exponential problem, which is basically any tree traversal, can be classified into exponential problem. Okay. And n factorial is permutation problem. For example, there are 1, 2, 3 elements, and then there can be a permutation of 1, 2, 3. It can be 1, 3, 2, 2, 1, 3, 3, 2, 1, or 3, 2, 1. Okay, 3, 1, 2, and 3, 2, 1. So basically 3 factorial, which is 6. So any counting problems or arranging items, okay, basically it's a permutation problem, which is n factorial. So okay, so whenever you find a tree traversal, you can call it as 2 power n. So whenever you find a graph problems, you can call it as n factorial. Okay, so basically any subset you want to build is basically a 2 power exponential problem. Any permutation you want to build is basically a factorial problem. That's all you want to remember. Okay, so order of n I spoke about is basically a linear time. Quadratic time is, you saw 2 for loops, right? That's n squared. So we spoke about it. Exponential time for any other tree traversal, it is 2 power n based on the available possibility, and n factorial, it's basically based on the permutation. Okay, so whenever you see a subset, you want to build a subset, it's exponential time. When you want to build any kind of permutation, it's n factorial. So you have to remember only these two right now for this understanding, because all other are simple things, and we'll be looking into this more and more as we go in. So this is clear, right? Any other questions here? Any questions? Okay, I think no questions, so we'll just move forward. Okay, fine. Okay, so this is very important, 2 power n and n factorial. So we'll dive little deeper into these problems. Okay, so we'll take one example. Maybe we normally do, right? When we want to go for lunch, we ask for what restaurant we should be going. So that is an extremely complicated problem. The complexity is too high. What normally happens is what? Because the problem was some will eat non-veg, some will not eat veg, some might not like any other continental cuisine or any other thing other than Indian cuisine. Some might have gone to the same restaurant many times. So when you choose, okay, what will normally happen? What we'll do is we'll either take a vote, okay, or what we'll do, somebody will say, let's go to this restaurant, and everyone follows, right? So that's the normal thing happens. It's basically a non-polynomial problem, okay, which is exponential in time, because if you start asking people, do you like it or not, and then after that, you again go back to saying that, you know what, this hotel is decided, can we go to this, and then ask people whether are you okay with that, and then it goes back, and then no, I don't like this hotel, so again we go back to this. So it's basically a subset problem. It goes back and forth, and finally we decide one solution. If the group is 6, it is easy to group 6 to 10, it is easy. If the group is 20, 25, it is very tough to decide because there will be too many permutation and combinations, and there will be many and the choice grows exponentially as the people grows. Okay, fine. So in that restaurant choice context, right, let's we revisit the n squared, 2 power n, and n factorial. Okay, so if you have any question, just post it in the window. I'll be able to answer that. Okay, fine. Any questions you have? Okay, fine. So, so let's go to the next slide. So we spoke about any order of n, right? I'm just going to skip it because if we take order s and no, and then just calculate s, and then we can figure out based on number of people, we will get order of n. N squared is nothing but what? You have similar food quality and price. For example, you want to find all the pairs of restaurants that are similar quality and price. We'll be able to what get on a specific threshold. We can figure out that, so it will be order of n squared. That is easier. So let's come back to the order of 2 power n. So that is little bit complicated because when we traverse to NP and NPR, we need to understand this exponential problem. Okay. Suppose you want to find a subset of restaurants with a certain minimum number of positive and negative reviews. Say you need to get a subset of 20, so either that restaurant will be available in the subset or not available, right? So we remember we saw the subset where we were able to figure out, say for example, there can be two subsets, right, which is optimal number, where there is a subset of this is value subset, and we will be able to figure out how many subsets can be built. With that, you remember 1, 2, 3, and we got one empty subset, 1, 2, 2, 1, 2, 2, 1, 2, 3, 1, 2, 3. So we got 2 power n is what? 2 power 3, 6, 8 subsets, right? So you remember this? I'll just go show you that. Okay, so 2 power 3, 8. Okay, so just keep this 1, 2, 3 as some kind of restaurant. When you want to set up possible subsets where there can be of negative some threshold, we'll be able to get the subset. Okay, so basically it's a order of 2 power n. So worst case is basically order of 2 power n. Next is the n factorial. So okay, this is little bit complicated. I'll just explain it to you. Hope you guys understand. How it works out is, say for example, a food critic comes, visits your restaurant, okay, and decides to try each dishes exactly once. They want to taste the dishes in various orders over multiple visits to evaluate how much this dish sequence affect their dining experience. Okay, so the thing with food is, right, so if you say for example when you eat a sweet and then you eat something more sweeter, you might not feel the sweetness, right? So same way, there is always an order you can actually keep so that the critic will come and try it out multiple orders, and then he will give you the review of that dish or the restaurant. Okay, so there can be, right, A, B, C, when A is an appetizer, B is a burger, C is a B, C, A, C, A, B, C, B, A. So it can be 6 choices, six different ways you can actually order it, so they can come and visit it. Okay, so as you said, the subset of positive and negative reviews is 2 power n in case of restaurant, and in subset of negative restaurant choices basically n factorial. Okay, why I am taking this restaurant choices? Because first we spoke about n squared, 2 power n, and those stuff. Then we came to n factorial, the restaurant choice, is because we want to compare these choices and get the data out of it. This is the cheat sheet. For example, say I have order of n squared is what? Look through size array and find all pairs of elements that sum up to 10. It's a polynomial problem. It's a bubble sort, right? Any bubble sort, anything. It will be 2 power n, creating a subset. We saw that, and it's exponential. N factorial, travel salesman problem, or having permutation problem or the restaurant problem. Okay, fine. So let's take a little detour. So we spoke about n squared, 2 power n factorial, right? Let's take a detour and come back to the complexity. Okay, right now we have actually came about the complexity which we have already studied, order of n squared, 2 power n and n factorial. Why I am coming this to the complexity for an architect is because you need to understand certain problems in a certain way. So for that you need to get to a basics of small mathematical basics before getting into the advanced concept. Okay, so what is this equation? This is basically what? It's a polynomial equation, right? Okay. Is there anything else we can see? Okay, if you have not subscribed to our channel, please do subscribe, so you'll be able to see all these videos like this. Okay, fine. So the polynomial, why we have to understand polynomial equation is, say for example, there are x number of friends. Okay, each friend takes each operation takes twice the time based on the number of operations, number of friends available. So the time taken is 2 of x, right? 2 times x. It can be multiple things. So x square, if for example, if you say x square, the time taken is x squared plus 2x minus 15, meaning we need to go and ask the other friend, and he goes and confirms with the friend who is sitting next to him, and then it takes if the friend is very close, it takes minus 15. Okay, so there is one complicated equation when we are choosing a restaurant. What will happen? It's basically equation, right? The x squared plus 2x minus 15. This will give you the time taken for that decision to be taken or the restaurant to be chosen, right? So basically this problem is, when it is smaller, it is solvable in p time, right? So when this is smaller, it's basically solvable in p time. But what if we are going for if it's a yes or no vote, it's all fine, okay? But we are searching in terms of say the reviews, or figuring out whether there is a wine available, or whether alcohol is available, whether non-veg is available. If you are adding more and more constraints other than yes or no, what will happen is it will become a exponential problem, because there are too many possibilities for that hotel itself. Is that clear? The possibility increases based on the number of options available. So it will be 3 power, 4 power. So n will be the number of people available. Okay. So it can be 3 reviews, or it can be alcohol available, non-veg available. So more and more options added, it will be n power, say m power x or m power n. Okay. So still this is a polynomial equation. So basically polynomial equation is nothing but it's based on, if it is a yes or no voting, it is simple problems. Any problem that is order of n or order of n squared is polynomial problem. Okay. But the exponential problems are the R problems, as we spoke about, right? Having positive and negative reviews, having more non-veg or veg available, whether it's closer to the office, whether we want to go a restaurant and then go to something else. So whenever more and more options are added, it becomes a exponential problem. Is that clear? Okay. Okay. So now we come back to the determinism, non-determinism with magical guess. Okay. So deterministic problem are problems that produces the same output for a given set of inputs every time it's executed. There is basically no random. Okay. Whenever I know there is a choice of the loop runs, and it runs in the same way. Okay. Non-deterministic program are programs that have different outputs for the same input, or sequence instruction due to presence of randomness or external factors. Okay. So deterministic programs are normal program we normally run. Okay. I just dive deeper into the non-determinism program. Okay. Non-determinism program is nothing but, say I have 2 functions. Okay. Say for example, find a restaurant or choose a restaurant. Okay. But choose restaurant A, choose restaurant B. At random time, sometimes it might call choose a restaurant A. Some random time it might call choose a restaurant B. Okay. But it's extremely random. Okay. The same function, it's a different for same function. Same call, but it calls a different function. Okay. But it will be random. So that is called non-determinism. I'll just give you a real-time example. As of now, you just think as a determinism is a normal program we write as a programmer. Non-deterministic program is you just write two programs and let the CPU decide which function to call, okay, in a program. Is that okay? Fine. So let's come back to the slide faster. Okay. So for example, then we have to understand what is called non-polynomial. Okay. So we understood polynomial, right? Any problem that solves in polynomial time is polynomial problem. Any problem that is solvable in exponential time is basically a NP problem. Okay, so for P problem and NP problem, there are two problems, P problem and NP problem. Solvable in exponential time is NP problem. Basically, there are three characteristics of NP problem, which is solvable in exponential time, verifiable in polynomial time, and also solvable in polynomial time by non-deterministic method. Okay, so we spoke about the non-deterministic right before. Okay, let's come back to an example with that, so you'll be able to understand more clearly. Okay. Is there any questions guys you guys have? Okay, fine. So choosing a restaurant, right? So what we'll do is, suppose a group of friends wants to dine out and try different restaurants in city. Each restaurant has a unique rating. The goal is to find the combination of restaurants whose total rating exactly equal a rating. Okay, there is some subsets, subset available or options available, possibilities available, and you also want to find the shortest route restaurant. Okay, so this problem is basically what is solvable in exponential time, but it's not verifiable in polynomial because we will not know this will go forever and ever. It might go even to a polynomial time. We'll just confirm the non-deterministic method. Okay, so let's take non-deterministic solution. Okay, let's revisit the restaurant problem, what we are trying to solve. Just out of this problem, right, there is one problem, there are multiple choices, and I'm just going asking, okay, do we want to go Saranabon? Are we going to go Punjab Grill or Barbecue Nation? Okay, everybody says no, and then somebody says, and almost everybody says yes. Okay, so this is a non-deterministic solution. Okay, what we have done is we have taken a optimization problem into a decision problem. Okay, whenever we can convert an optimization problem into a decision problem, it's basically called non-deterministic solution, because we took an exponential problem, we just jumped into the solution. I told you, right, there is multiple functions available. I just took a function or a question at randomly. So you remember that. So whenever there is a problem that is happening and I am figuring out a non-deterministic solution, which is not a for loop or if loop, I am just asking a different question to solve the problem. Okay, so this is the non-deterministic solution where there is a restaurant problem, and then I am just out of the blue, I am just coming and asking, you know what, like cut all that, can we go to this or not? So this is a non-deterministic problem. Now what will happen? So the question was, would all be optimally happy? Say for example, go to Barbecue Nation. So now it's solvable in still it is a solvable exponential time. It's verifiable in non-polynomial time, and also solvable in non-polynomial by non-deterministic methods. Okay. So now the optimization problem is reduced to decision problem. This is the Venn diagram. So P, NP, and NP-ARD. So okay, so there is a polynomial problem, and the polynomial problem has a NP problem. We'll come back. We'll come back to this NP complete and NP-ARD. Okay, NP complete is nothing but, so NP-ARD is a problem that cannot be solved. Okay, so for example, there is multiple choices. There are the traveling salesman problem that can be solved. But when I bring a deterministic solution, meaning asking this type of questions, it becomes NP complete. Okay, so it's basically a subset of NP, but it was NP-ARD. Once there is a deterministic solution, it becomes NP complete. Okay, so I think mostly you would have got about this. Okay, any other questions you guys have? Okay, so when NP-ARD problem can be solved using non-deterministic algorithm, it becomes a NP complex problem. Okay, so any problem that cannot be solved, okay, that can go through infinite loop, or it is extremely complicated to solve, then it is NP-ARD problem. But we have a non-deterministic algorithm. The questions I asked for that restaurant, right? It becomes a NP complex problem. Okay, okay, fine. So now we'll compare what MLS NP problems are. Okay, so say we'll just say for example machine learning. Any examples of machine learning problem is image classification. Any NP problem is a traveling salesman problem. Okay, so in comparing to machine learning, NP problems are typically much harder to solve because they require an exhaustive search for all possible solutions. It can take exponentially long time. Basically, any machine learning problem to figure out the actual solution, it takes exponential time. So NP problem and machine learning problem can be related in those terms. Major point is, okay, so any feature selection hyperparameter tuning can be solved using a NP complete, because saying if you find any deterministic way to figure out, okay, let me choose these features because but as a domain knowledge it is right. Okay, so when you can figure out some deterministic problem, you can actually solve the machine learning problems. Okay, so if you can classify any NP complex problem using any deterministic algorithm, then it becomes a machine learning problems can be solved using NP complete or NP art problems. So the major thing is the heuristics or approach normalization finds optimal solution that is completely feasible to compute. Okay. Okay. So major takeaway from this is, the overall takeaway should be, so you have to understand what is order of n squared, order of 2 power n or m power n. Okay, based on the possibilities, order of n factorial. So order of any m power n or 2 power n is basically what? Possible subset. N factorial is basically permutations. Any problem can be classified into polynomial or exponential or factorial. That is a major thing. If the problem is exponential, it can be classified as NP problem. Okay. If there is a non-deterministic algorithm, it can be classified as NP complete problem. In case of restaurant, when the optimal happiness question is asked, it became a NP complex problem, complete problem. Okay. Otherwise, it will be a NP odd. Any travel salesman problem is still an NP odd problem. If you can ask the question, if there is a shortest path for the traveling salesman, then it becomes a NP complete problem. Okay. So in case of machine learning, if you can randomly select features, it becomes a non-deterministic way of doing things. So any ML can be classified as any ML hypertuning or feature selections can be classified as what is it? NP complete problem. Okay. So this is a big shout out about my book which I wrote regarding architects. If you want to become an architect, if you want to learn more about architects, this is a good book to read. You will learn how to communicate with your stakeholders, how to make sure that you work with your stakeholders. What is the next things you need to learn? What are the basics you need to understand to become an architect? What are the things you should know to become an architect? This not only talks about technology, but also talks about how to become an architect. What are the things you need to change in yourself to become an architect? Okay, this book is very widely used. You can go and check it out in Amazon. Okay, it's named as Developer Road Ahead. It has very positive reviews. Okay, just please go and check it out. Fine, thank you. Is there any other questions you guys have? Okay, thank you.